Hey y'all, I wanted to do a quick review. Some of these I already went over, but for those of you who may have missed, I want to do some practice over complex inheritance. Remember, complex inheritance is not just about having a dominant allele and having a recessive allele like in Mendelian inheritance. Okay, complex inheritance, there's a few other different inheritance patterns, and I'm going to go over four of those. Okay. Number one, Homer has decided he wants to go into the dog breeding business and wants to use Santa's Little Helper. Santa's Little Helper is heterozygous light brown. So his genotype, listed right there, is B, B prime. Okay? This is a combination of dark brown, represented by just a B, and white, represented by a B prime. Homer wants to get puppies that are dark brown, light brown, and white, and has two choices of dogs he can mate with Santa's Little Helper. Penelope, who is also light brown, notice her genotype is the heterozygous one. I'm going to go ahead and highlight Penelope too with the same color. And then Samantha, who is white. She carries both B prime alleles. Okay, she's homozygous for B prime, and that's Samantha. Okay. A says create a Punnett square for Santa's Little Helper and Penelope. So Santa's Little Helper and Penelope. Notice they're both highlighted green here because both of them are heterozygous. Both of them are light brown. Now, one thing to remember is that when you're following or when traits are following a pattern of incomplete dominance, if you are the heterozygote, meaning you have both alleles, the alleles in this case are B, which represents brown, and B prime, which represents white. So when you think of incomplete inheritance, you should be thinking of in between when you get a heterozygote. So what's in between brown and white? Light brown. Both Santa's Little Helper and Penelope are heterozygotes. Both Santa's Little Helper and Penelope have light brown fur color. So let's go ahead and start our Punnett square. All right. Now, what I'm going to do is I'm going to put both parents, Santa's Little Helper, who is heterozygous, he's light brown, he's B and B prime. Penelope is also light brown, so she'll be B and B prime. Let's do our cross. B, 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 B prime, B, B prime, and B prime, B prime. All right, what are the probabilities for the phenotypes? Well, our options are for them to either be white, which would be B prime, B prime. The white allele is B prime. Light brown, which is B, B prime. Or dark brown, which is B prime, B prime. All right, so how many of these offspring boxes indicate a white fur color? If you said the bottom right one, you would be correct. Just one. So 1 out of 4, which is the same thing as 25%. There's a 25% chance that the offspring between Santa's Little Helper and Penelope will be white. What about light brown? Light brown is the heterozygous genotype. It has both letters B and B prime. And look, got 1, 2. So 2 out of 4 of the offspring, 2 out of the 4 boxes are for heterozygotes that will be light brown color, or the offspring have a 50% chance to be light brown. Finally, what about dark brown? B prime, B prime? Excuse me, I have wrote that wrong. Let me fix that. That's just B, B, not B prime, B prime. Hopefully you caught that before I got to this point. But how many of the boxes represent BB, or the homozygous B genotype? Right there. And that indicates dark brown. So 1 out of 4 equals a 25% chance that the offspring of Santa's Little Helper and Penelope will be dark brown. Now let's look and see what it's going to look like if Santa's Little Helper mates with Samantha. And Samantha is white, which we're going to highlight her yellow. Give the probability of the phenotypes. We're going to do the same thing we did above. And I'm just going to copy my Punnett square over, so just bear with me for a second. And I've already kept Santa's Little Helper there at the top because he's still going to be part of the mating process. The difference here is going to be he's going to be mating with Samantha. Now, what color is Samantha? White. So what is her genotype? She is homozygous for B prime. So she's B prime, B prime. Let's do her cross. B, B prime, B, B prime, B prime, B prime, B prime, B prime. Hopefully I did that right, and it looks like I did. I'm going to copy our possibilities from the top here and bring them down. So what's the chances that we get an offspring that's white, which is the homozygous B prime genotype? 2 out of 4, just those 2. So 2 out of 4, which gives us a 50% chance of having puppies that are white. What about light brown? Do you see any that might be white, light brown within these boxes for the offspring? No, me neither. So that means we have a 0 out of 4 or 0% chance that any of these puppies between Santa's Little Helper and Samantha are going to be light brown. What about dark brown? Yep. There's 2 boxes with the dark brown genotypes, B, B prime. Oh, I just messed up again, kids. You're probably screaming at me right now. So, there's actually no dark browns. There's no BBs. But there are 2 light browns, BB primes, 2 heterozygous genotypes for fur color. Hopefully you were screaming at me and you saw where I was messing up. So 50% are light brown. Okay. So C asks which female dog, Penelope or Samantha, would give the Homer the puppies that he wants and why. What type of puppies does Homer want? Well, if we look back to our paragraph up here, it says Homer wants dogs or puppies that are dark brown, light brown, and white. So he wants all possibilities. Okay? Which mate, Penelope or Samantha, will give Santa's Little Helper, will give Homer all breeds, all colors of puppies? Hopefully you said Penelope. Because if you look, there's at least a chance that Penelope and Santa's Little Helper are going to give them all fur color types. If he was to mate with Samantha, there would be no dark brown phenotypes. There would be no dark brown puppies. So the answer is Penelope. Why Penelope? Because she will give Homer all of the puppy colors that he is looking for. All right, so that's the only one I'm going to do in this video. I will separate videos. So this video was just over incomplete dominance. Incomplete dominance, remember, is when the heterozygote, the genotype with two different letters, falls somewhere in between the two homozygotes. In this case, the heterozygote represents the light brown phenotype. The homozygotes are white, B prime, B prime, and dark brown, BB. But like I said, if you get the heterozygote, BB prime, you get something in between white and dark brown, you get light brown. All right, hopefully that helps you guys.